NASA launches a rocket at t equals 0 seconds. Its height in meters above sea level as a function of time is given by the function h of t. We will assume the rocket will splash down into the ocean. We want to answer two questions. 1, what time will the rocket splash into the ocean? And 2, how high above sea level will the rocket reach? Now we just solved this problem using a graphing calculator, but now we're going to solve it using what we know about quadratic functions and quadratic equations. So before we solve this, I think it's going to be helpful to understand what's happening if we graph this function. So I've already graphed this using some graphing software. So our x-axis represents time in seconds, and our y-axis represents the meters above sea level. Notice at time t equals 0, the rocket would be right here, which would be the y-intercept. This represents the initial height of the rocket, and then as time passes, the rocket goes up, reaches a maximum height here at the vertex, and then comes back down to the Earth. And when the height reaches 0, that would be when the rocket splashes into the ocean, which would be this point here, which would be the x-intercept. So to find how long it takes for the rocket to splash into the ocean, we want to find the x-intercept. And to find the maximum height, we want to find the y-coordinate of the vertex. So let's go back and do that. Again, to find when the rocket splashes into the ocean, we know the height above sea level, or h of t, would be equal to 0. So we want to solve the equation 0 equals negative 4.9 t squared plus 310t plus 332. Well, this is not a factorable quadratic equation, which means we'll have to solve it using the quadratic formula given here below. So for the first step, we need to recognize that a is equal to negative 4.9, b is equal to 310, and c is equal to 332. Again, this is based upon the fact that we're using the function h of t equals at squared plus bt plus c. So now we'll sub these into the quadratic formula and then evaluate. So instead of x equals, we'll have t equals negative 310 plus or minus the square root of b squared, or 310 squared, minus 4 times a, which is negative 4.9, times c, which is 332, divided by 2 times a, or 2 times negative 4.9. Now we'll simplify this in pieces. We'll have t equals negative 310 plus or minus square root of the value of this expression here, which is the discriminant. We'll come back to that, divided by negative 9.8. So now we'll go to the calculator and determine the value of the discriminant, or this expression here. So we have 310 squared minus 4 times negative 4.9 times 332. So the discriminant, or the number underneath the square root, is 102,607.2. Now notice, because of the plus and minus, we are going to have two solutions. Remember, t represents the time in seconds, and t can't be negative. So one solution is going to be negative, which doesn't make sense, so we'll exclude that one, and then we'll only use the positive value of t for the time when the rocket splashes into the ocean. So we'll put the numerator in parentheses. So we'll have in parentheses negative 310, let's use plus the square root of our discriminant, one closed parenthesis for the square root, another one for the numerator, and then we'll divide this by negative 9.8. Notice how this value is negative, and since time can't be negative, we're going to use the second solution, so we're going to change this plus sign here to a minus sign. We can do that by pressing second enter, which brings up the previous expression, but we can now edit it. So I'll change this plus sign to a minus sign, and then press enter. So the time is going to be approximately 64.3 seconds. And then for the second question, to determine how high above sea level the rocket will reach, we'll have to find the vertex of our parabola, where the x-coordinate, or t-coordinate in this case, is negative b over 2a, and the y-coordinate would be the function value when t is equal to negative b over 2a. So the first step, we need to determine the x-coordinate of our vertex, which is going to be equal to negative b over 2a. So we'll have negative 310 divided by 2 times negative 4.9. We'll do this on the calculator. We do need parentheses around this product, so 2 times negative 4.9. So we'll say it's approximately 31.63. Again, this is the time it takes to reach the high point above sea level, but the question is, what is the function value, or what is the height above sea level? So our ultimate goal is to find h of 31.63. So we're going to substitute 31.63 for t in our function. And this will give us our maximum height. So we'll go back to the calculator one more time and determine this function value. So the maximum height is going to be approximately 5,235.1 meters above sea level. Okay, so I think we're done now. We've answered both questions. I hope you found this helpful.